Ready for Brahmari pranayam? Keep your thumb in your ears and start. Take a deep breath in and get relaxed. रेडी फॉर राम नाम? सब लोग मेरे साथ गाएंगे। राम 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 राम। Keep on your eyes. Slowly open your eyes. Jai Gurudev. Okay, sir.
Good morning and welcome present over here. Today we are comes together to celebrate the National Mathematics Day on the occasion of birth ceremony of the great mathematician Srinivasa Ramanujan. The mathematics is not about numbers, equations, computation or algorithms. It is about understanding. On 22nd December 2012, the former Prime Minister of India, Dr. Manmohan Singh, paid tribute to Srinivasa Ramanujan at the function organized on the occasion of the birth anniversary of the great mathematician Srinivasa Ramanujan in Chennai. 22nd December was declared as a National Mathematics Day. Thus, 22nd December 2012, National Mathematics Day was celebrated across the country for the first time. Now, the student Unnati Gandhi of class 6 is going to express her thought in Hindi. Please, Unnati. Unnati, please unmute yourself.
Good morning, Jai Gurudev. My name is Unnati Vivek Gandhi. Today I today I will express some views on International Mathematics Day. International Mathematics Day is celebrated on 22 December every year. National Mathematics Day. It is observed on 22 December every year to mark the birth anniversary of legendary international mathematician Srivansa Ramjun and his contribution in the fields of mathematics. Let us more about National Mathematics Day. It is celebrated on 22 December every year. Since ancient times contribution of mathematics including Aryabhat, Brahmagupta, Mahavira, Bhaskara II, and Srivansa Ramjun, etc. At a very young age, Srivansa Ramajun showed signs of unfolding genius. Set an example in mathematics. National Mathematics Day history on 22 December 2012 and formed Prime Minister of India. Mohammed Singh paid a tribute Srivansara Ramju at a function organized on the occasion of the birth anniversary of a great mathematician Srivansa Ramajunu. In Chennai, 22 December was declared as National Mathematics Day across the country and in the first time. Thank you.
Superb, excellent Unnati. Now, our student Janvi Khade of class 6 is express her thought in Hindi. Please, Janvi.
सुप्रभात जय गुरुदेव। मेरा नाम जानवी दौलत खाड़े है। भारत में राष्ट्रीय गणित दिवस महान गणितज्ञ श्रीनिवास रामानुजन की याद में मनाया जाता है। श्रीनिवास रामानुजन की गणना आधुनिक भारत के उन व्यक्तित्वों में की जाती है जिन्होंने विश्व में नए ज्ञान को पाने और खोजने की पहल की। आपका जन्म 22 दिसंबर 1887 को मद्रास से 400 किलोमीटर दूर ईरोड नगर में समय उनका परिवार ईरोड से कुंभकोणम आ बसा। श्रीनिवास रामानुजन एक दक्षिण भारतीय ब्राह्मण परिवार से संबंध रखते थे। आपके पिता कुंभकोणम में एक कपड़ा व्यापारी के मुनीम का काम करते थे। रामानुजन की आरंभिक शिक्षा कुंभकोणम के प्राइमरी स्कूल में हुई। तदुपरांत 1898 में आपने टाउन हाई स्कूल में प्रवेश लिया और सभी विषयों में बहुत अच्छे अंक प्राप्त किए। यहीं पर रामानुजन और आपने कार्य करना प्रारंभ किया। अधिकतर विद्यालय में आपने दोस्तों से किताबें उधार लेकर पढ़ा करते थे। गणित के अतिरिक्त अन्य विषयों में रुचि न होने के कारण वे कठिनाई से परीक्षा उत्तीर्ण कर पाते, लेकिन गणित में वे 100% अंक पाते की आपूर्ति हेतु रामानुजन ने क्लर्क की नौकरी कर ली, जहां वह अक्सर खाली पन्नों पर गणित के प्रश्न हल किया करते थे। एक दिन एक अंग्रेज की नजर इन पन्नों पर पड़ी गई, जिसने निजी रुचि लेकर उन्हें ऑक्सफोर्ड विश्वविद्यालय के प्रो हार्डी के पास भेजने का प्रबंध कर दिया। प्रो हार्डी ने उनमें छिपी प्रतिभा को पहचाना, जिसके बाद उनकी ख्याति विश्व भर में फैल गई। धन्यवाद।
Excellent, very good, Janvi. Now I introduce today's our chief guest, Madam. Now our student Miss Shalvi Shah is going to represent one mathematics stream. Please, Shalvi, Madam. Very good, Shalvi. Now, I introduce our today's chief guest, Mr. Amol Gaikwad. He's completed her MSc NET JRF and he's working recently at Government College, Daman. Now, I request to Mr. Amol sir, please explain your thought and please guide our student. Please, Amol sir.
Thank you, sir. Am I audible?
Yes, sir. Yes.
Okay. So first of all, thanks a lot, organizing committee and principal, that you are invited me for the interaction of your on Ramanujan Day, on National Mathematics Day with your students. So basically, as I come to know that the students are from first standard to 10th standard. So I would like to interact first of all with the students, and then we will topics, journey of mathematics from ancient to modern. So when we read that word ancient, what that means to you is important, and then we will try to analyze, is it a cycle or is it just the beginning and then towards whatever we are right now. So basically the thing is like that we try to analyze the ancient era as well as the modern era. We have specific concepts based on that. As you all know, we are thinking about mathematics, so mathematics means numbers, and when we are talking about numbers, we have some number systems. So I would like to know the number system that you know. Maybe the very first that you may be aware of is set of natural number, or the number system which contains all the natural numbers. Do you tell me which is the first number in our natural system? First natural number that we know. Is it okay that if I share my screen? Okay, zero. Zero. Okay, one. That's good. Okay. So zero is not the first natural number. It is whole number. But one is the first natural number. Then our sequence starts. So 1, 2, 3, 4, and up to so on. I think instead of showing the screen, I will share my screen so that you can just observe my screen clearly. Is it visible? Whether my screen is visible or not? Kiran sir? Hello?
Yes, sir. Yes. Audible.
Okay. Okay. Is it visible? My screen is visible?
No, sir.
No. Just a moment. Now, is it visible?
No, sir.
Yes, Shubham sir. Is it
No, sir.
visible or not?
Not
No.
visible. Not visible.
Okay. So just forget it. We will just stop. So when we consider about these numbers, that the first
Yes.
natural number is now, is it visible? Okay. So one is the first natural number, second is the second one, then third, and like that. The first thing that you must ask yourself, that why this system is called as natural number system and not other system. As we can say that one is the first natural number, then second, then third, then fourth, and up to so on. This is nothing but the counting. So why there is need of counting anything? That is the first question that you must ask yourself. Why we need counting? And then we have to go to the era of which we are talking about, ancient era. Suppose there are some people and they need some kind of calculations, like which kind of calculations they will need if they don't have number systems and like that. If we assume a farmer and suppose that the farmer had some goats, he had some buffaloes, he had some cows and like that, and he has to uh, remember one thing, that whenever he went outside for some work and when he come back, the number of animals or the number of cows must be same. If the number is not getting matched, then he surely think that something is missing. So for that, he started taking stones for each and every cow or each and every animal. Suppose there are 3 or 4, then for each and every one, he just have a stone, 1, 2, 3, 4, and 5. It's just nothing but the 1-1 correspondence that he gave to the each and every animal and to the stone. And from that, he starts the counting. So counting generally begins with 1, 2, 3, 4, and up to so on. There is no zero in it. Now the question is, when we add 0, we know that the system becomes whole number. When we add negative natural numbers, that we know that the whole number system is starting from 0, 0, 1, 2, 3, up to so on. And if we add negative naturals, it becomes integers, set of integers. That is maybe -3, -2, -1, then 0, 1, 2, 3, up to so on. But again, the question carries the same thing, that we don't know which these numbers, we haven't made them. This is just our imagination. So if this is just our imagination, then why there is need of such imagination? Even if when you wake up today, you just saw the alarm clock or you just saw the clock that it is 7 a.m. or it is 6 a.m. But exactly you don't know what is 6 a.m. It's just your imagination that this is the particular time of a day where you have just passed 6 hours from 12 p.m. or 12 midnight. What's that connection exactly? How we distribute these days, these years, these hours into specific time interval? And that time we have to go to the ancient era, where there are some mathematicians who developed their theory. Based on that, our modern time and our modern calculations are based. So there is a connection between ancient era as well as the modern era. So basically, when I talking about ancient, I mean those who contributed to the mathematics, and there are evidences that there are some written things or there are some tablets which expresses that these civilizations give a credit to particular concepts, and from those we have developed new theories. So first we will go about the time. In time, I mean, what about day? What about hour? What about seconds? The very first question that come to my mind is that why 60 seconds makes 1 minute? Why 60 minutes makes an hour? And why 24 hours makes a day? Or in general, why there are 12 hours for day and 12 hours for night? When we come to these questions, then we understand there are civilizations, but the most important of those were Sumerian and Babylonian. Sumerian and Babylonian. These are the civilizations about whom we will talk. Specifically speaking, we are using decimal number system. Decimal, you all know, binary means base 2, but instead of decimal or instead of binary, Sumerian and Babylonian, they use different number system. They use sexagesimal. Sexagesimal means base 60. Now, why they use base 60 number system instead of base 10 and base 2? That is the next question. Now, if you observe your hands, then just observe there are 15 finger joints in your one hand. There are 5 fingers. Each and every finger is jointed by 3 finger joints. So 3 into 5, that is 15. Your one more hand, it has 15 finger joints. So 15 plus 15 becomes 30. And usually Babylonian consider a pair. So pair means 2 men and women. So 50 into 4, that is becomes 60. That's their way of calculating. So when they consider the base 60, the other thing is that how they observe 24 hours for a day. For that, the very first thing we have to go is the sexagesimal base system was used by Egyptians also. Egyptians are far more abstract. They are far more advanced as compared to Sumerians and Babylonians. What they do, they observe sun and they put a simple stone. Due to that stone, they can observe some shadow. And with respect to shadow, they can count time. If the sun is here, then the shadow is different. If the sun is at this position, then the shadow is different. And they observe that with respect to this shadow, they need at least 12 cycles to understand time interval. 12 cycles to understand time interval. Then they come to conclude that equivalent intervals which can map the whole day with respect to the daylight or the sunlight. So 12 equivalent intervals which can map the day as well as, but the other thing is that the difficult part is how you can map night, because there is no sunlight. So without sunlight is very difficult to map the night intervals. So they observe stars. Basically they observed 36 stars. 36 stars, out of which there are 80 which are visible by naked eye. And those 18 stars have the phenomenon that when the sun rises and when the sun sets, they are visible throughout. Out of these, there are 3 stars which are not that much bright when there is sunrise, and there are 3 stars which are not that much bright when there is sunset. So excluding these 3 and these 3, we have 18 minus 6, that is 12. So they come up to the conclusion that there are 12 stars which can be considered as a basic steps to calculate the time interval during night period. And for that night period, they use water clock. There is a specific type of instrument which has certain pressure, and that pressure brings the water down. During these time intervals, during these 12 time intervals, they calculate other systems with respect to this. So the thing is like that we have 12 specific intervals for day, and there are 12 specific intervals for night. Now this is just the pure theory work, nothing much more interested in that. But the basic questions comes next. Now I expect answer from you. If I wanted to get a smallest number which is divisible by 1, 2, 3, 4, 5, 6, then what will be that number? Tell me the number which is divisible by this and which is smallest. The number which is divisible by 1, 2, 3, 4, 5, and 6, which one or two students can unmute themselves and give the answer. Is it 30? Am I audible, sir? Shubham sir, Kiran sir, am I audible?
Yes, sir. Yes, sir.
Okay. So my question is, which is the smallest number that is divisible by 1, 2, 3, 4, 5, 6? My next question is it 30? Then specifically you can see that 1 divides 30, 2 divides 30, 3 divides 30, but 4 does not divide 30. Again 5 divides 30 and 6 divides 30. So 30 is not the number. So which is the smallest number that is divisible by these all? If you're giving your answers in chat box, then I cannot see those. But I hope most of you get up the right answer, conclude with the right answers. The right answer is 60. 60 is the number which is divisible by 1, 2, 3, 4, 5, and 6. As well as it is divisible by 12, 20, 30. Even with 60, with 15. Okay, that is enough for us. Now what this means? This means that, yes, with 10 also you can divide 60. All the base systems which we know still far, which has base 10, which has base 12, which has base 15, they can all have a common multiple which is 60. So they come to the conclusion that 60 is the most convenient number that we can use for the separation of hour, for the separation of second, and for the separation of hours that we have right now. We have the intervals, 12 intervals for night, 12 intervals for day. So including those, there are 24. So 24 intervals in a day. We can distribute these intervals in such a way that every part of those intervals is must be multiple of 6. So they come up with the conclusion that the very small part or the very small section of this interval must be 60. Now we call it that 60 seconds is equal to 1 minute. This was used another mathematician or astronomer, Egyptian astronomer, uh, Hippo just he's astronomer. He took all from the data that have that, it is called as 1. When they want to express 2, this is the first, this is their number 3. When they express 4, now it is interesting. They don't go for the second stick, they just add it here. It is 4. Then if they want to know what is 5, they just add more. This is 5. Then 1, 2, 3, 4, 5, and 6. This is 6. Similarly, this is number 7. They don't know what is this number. Is it in hexadecimal? Is it in decimal? We don't know. But if we want to express using Babylonian, then this number must be like this. It's like this. Then 5. So 1, 2, 3, then 4, and 5. Then 35, which means that a smaller gap between these. This is 10. This is 20. This is 30 and 5. So there is 1, 2, 3, 4, and 5. So this is the number system that they produce. Now another thing is that this is 10.5.35, but we don't know what is exactly they mean by the number. Now there are so many scientists and they have a certain debate on that how they conclude this system. This can be 10 into 60 square plus 5 into 60 plus 35 into 1 by hexadecimal system, or it can be 10 into 60 plus 5 into 1 plus 35 into 1 upon 60, or 60 to the power minus 1. How am I writing this? Because we have the decimal expansion, we have decimal system. If I wanted to write, let us say 125.04 in decimal system, then I know that how am I writing this? This is nothing but 1 in square plus 2 into 10 to the power 1 plus 5 into 1 plus 0 into 10 to the power minus 1 plus 4 into 10 to the power minus 2. So like this, if this is decimal expansion, then hexadecimal expansion must be like this, into the power of 60. So that's how they took terms. The interesting part is that their multiplication and their division. How they divide, how they multiply, actually they use the converse operations or inverse operations, we can say. So they are dividing by some number, they use its inverse and multiply by that. For example, if I want to multiply the numbers in Babylonian, multiplication in Babylonian system, now this is interesting part. Let us say 12 into 2. Now this is very easy, it is 24. Now we know that 24 can be written in 60 base system. It is not 1, it is not 1/4. But if I want to divide this number, then this is 12 by 2. Now it is not equal to 6 in Babylonian system. Why is it so? They use a different track. Inverse of 2 in Babylonian is the number such that 2 into x is equal to 60. This implies that x must be 30. So instead of dividing 2, they multiply 12 by 30. So 12 into 30 is their product, which is 360, which is nothing but 6. Why? Because we are talking about system in which 60 is the base. So 60 means 1, 120 means 2, 180 means 3, 240 means 4, and like that. There are 6 intervals. Therefore, their answer is 6, but their calculations are in a different sense. Now, these cells are helpful for the calculations. Right now, the study shows that in modern era, we observe that the Babylonian system was far advanced as compared to our system. Why is it so? Because they have so many advantages over decimal number system. So when we compare this system, their logical evidences and their corresponding numbers, their simplifications, their multiplications, their additions, their divisions, and the astronomy that they developed, then we found that this system had some certain importance and it is very useful for the future study. Because we know that even when we talk about ancient era, we know that the mathematics or the science was developed at that era also, but we don't have evidences that can express that yes, they were very developed. But we don't know that whatever they have constructed, whatever they have, like the calendars, that like the astronomy that they persist, is at a different level. Now come to the other part of this system. Is there any specific relationship between these numbers? Like in our decimal number, I would like to give a particular incident. I would like to share an incident. As you know that Ramanujan was a very clever guy, and generally the bad thing that happens with each and every clever guy or the person is that they don't have so many friends. So Professor G.H. Hardy once asked Professor Ramanujan that why don't you have so many close friends? And his reply was like, I want to have close friends, but there are no which can come up to my conclusions or which can come up to my expectations. And Professor Hardy was confused. He asked, why is it so? Then he said that I would like to have those friends which are like 220 and 284. When he said that I would like to have friends like 220 and 284, the person was get confused. Why is it so? These are the numbers, and is there any relationship between these? Yes, there is a relationship between these in decimal expansion or in decimal system. What is that relationship? Let us see the relationship between these numbers. If we calculate the divisors of 220, the numbers which can divide 220, then we can clearly see that 1 divides 220, then the second number, yes, 2 divides 220 because 220 is even number. Then 4 divides 220, as well as 5 divides 220, 6, no, 6 cannot divide 220, not 7, not 8, not 9. Yes, again 10 can divide 220, 11 can divide 220. Then I think 20 divide 220, 22 divides 220. Then not 25. Yes, 44 divides 220. Then 55. Then 110. And finally 220. These are the only divisors of 220. Excluding these, there are no other divisors of 220. And the other one is 284. So divisors of 284. Again, 1 divides 284, 2 divides 284, 3. Okay, no, 3 doesn't divide 284. 4, yes, 4 divides 284. 5, no. 6, yes, again 6 does not divide 284. 7, no, I think the remaining terms they don't divide 284. The next number that divides 284 is 71. Then 142 and 284. How we calculate this? You know that you can have prime factorization of 220 and 284. So these are the divisors of 284 and these are the divisors of 220. So what Ramanujan wanted to say about these two is very interesting. What he wanted to say is that if you subtract all the divisors of 220 from itself, that means if I subtract 220 minus 1 plus 2 plus 4 plus 5 plus 10 plus 11 plus 20, plus 22 plus 44 plus 55 plus 110. Tell me the result, what I get. If I subtract the addition of all the divisors excluding 220, then what is my final result? Yes, are you calculating? Anyone?
Yes, sir.
Okay. Others will calculate the other sum, that is 284 minus 1 plus 2 plus 4 plus 71 plus 142. Okay. I think this one is very simple, so I can do 1 plus 2 3, 3 plus 4 7, 7 plus 1 8, 8 to 10, 5 7 12. रिक्वेस्ट के तौर पर कोई कहे तो उसको जान दे देंगे रिक्वेस्ट के तौर पर कोई कहे तो उसको जान दे देंगे ये ऑर्डर की जब बात आती है तो दिमाग खराब यस this will become 220. You will come later, na? So the difference is 60 and this will become, I must say it must be 284. Am I right? This addition must be 220 and this addition must be 284. Am I right or wrong? This is the right thing, I must say. So what this relationship means? This relationship means that if you have this number 220 and 284 and if you take divisors, then if the other person is absent, if 220 is absent, then you just take the remaining divisors and add them. You will have that person or you will have that number 220. Similarly, if 284 was absent, you just take the divisors of 220 excluding 220, add them, you will have 284. So basically they are complement of each other. You will say that 284, there is no 220 in 284, but yes, there is 220 in itself. How? You just have to take certain mathematical expression, that is nothing but addition of its all divisors excluding the term itself, and there is 284 in 220 if you did the same operation. So which means that mathematics is not just the calculations, it is an idea, and this idea is the expressions that come up with the conclusions. Even Ramanujan once said that an equation for me has no meaning unless it expresses a thought of God. So according to him, if there is an idea, if there is an particular thought of God, then we have to express that in mathematics, in terms of mathematics. So in terms of mathematics, if we want to find some relationship between this, then the open question for all of you is that find a correspondence or find a relationship between this number system, Babylonian number system, and the other systems that we know. The other systems that we know are Roman number system as well as Indian or Hindu Arabic, we say that Hindu Arabic number system. So is there any specific connection between this Babylonian number system, between Roman number system, between Hindu Arabic number system? Is the question that everyone should ask themselves. Is there any correspondence between the operations or the binary relationships between the numbers? Operations in the sense binary multiplication, binary addition, binary division, like those. If there is any certain relationship between those, then how we can adopt that? If we know about that, then so many theories are there which will interact with the era that we call as ancient era or ancient mathematics. So that's the conclusion, I think, for the day. What I wanted to say was there is a connection between ancient mathematics and modern mathematics. The very connection is our time, why we call 60 seconds a minute, why we call 60 minutes an hour, and why we distribute our whole day in 24 hours. There is some evidences that it based on ancient system which was used by Babylonian. The Babylonian has a different number system. They don't have zero, but they do have their multiplication, they do have their addition, they do have their divisions with the base 60. So can we develop our theory with respect to that number system? Is there any correspondence or is there any relationship between that system, between Indian Hindu Arabic number system, between Roman number system, and is there any relationship that we can give about all these numbers and the astronomical units? So that's for the day. Once again, thank you for your time. Over to you, sir.
Yes, thank you, sir. It's really very informative and very expressive speech from the Amol sir. Now, I would like to request Mr. Kadlak sir for the vote of thanks. Please, Kadlak sir.
So a very good morning, everyone, and wish you first of all a happy National Mathematics Day. It gives me an immense pleasure to deliver the vote of thanks for this event. Event of all dignitaries assembled here. I would like to thank our guest, respected Mr. Amal Gaikwad sir, who honor with this function with his productive speech. I would like to express my gratitude to respected President and Secretary Swati Shah Madam and Samir Shah sir. My big thanks to our Principal Sapra Ma'am and Vice Principal Chavan Ma'am, staff members with all speakers, and last but not the least, our beloved students for making this function as good as success. So thank you everyone for joining today. Thank you.